Alright, so Elaine bothering me again as usual. Okay, here we go. So, I haven't actually read the questions. Let's begin. 2011 multiple choice question 18. Okay, so the equation x cubed minus 9x squared plus 15x plus w equals 0 has only one solution for x. When? Okay, so obviously w will change the problem. Oh man, my pen's not even working. Wait, I have to do something. I think I close this and maybe I reopen it again. Does that work? Draw. Let's go down. Alright, cool. So, that W is really just a translation, and you want to know when you have, because it's equal to 0, notice it's equal to 0. If it's equal to 0, what that does is you're really just finding out your x-intercepts. Man, that's terrible. Just in case you haven't realized, I don't have my tablet. I'm using a sort of writing pad. That's why it's weird. Okay, so this is a translation up or down, and you want to make sure that this cubic graph only has one x-intercept because you're letting y equal to 0. So you're really solving for the x-intercept. So the question is, what does this graph look like? Because if you know what the graph looks like, you can ensure you will have one solution or not. Now, this is a cubic graph. It's a positive cubic graph. You could potentially have these following graphs. You could either have it looking like that, where there's only one stationary point of inflection, but then that would make sense because that means technically any value is always going to give you one solution. And I highly doubt that function there is this type of graph. It most likely would look like this because it's a positive graph, okay? So if it does look like the second scenario, well, with the second scenario, you see the problem is you can have 1, 2, 3 intercepts. Or if you shifted the graph up slightly, you can get the graph to just 1 and then maybe 2 x-intercepts. You see that? 2 x-intercepts. But what you want is, you see, the main thing is your turning points. Your turning points would dictate how many intercepts you can have. Now, if I shifted this graph high enough, okay, if it was high enough, it could have been up here, where I only have one x-intercept and it turns back. So I only get one x-intercept here. So what you want to know is, well, where is the largest y value, which is here, and the lowest y value that it can be to ensure that you don't get two x-intercepts like I did with the green graph. Okay, so again, I'm going to draw it again just in case you're confused like you normally are. This is my cubic graph. What I don't want is, you see that minimum, I don't want that minimum to touch the x-axis. So this will tell me, if I can find that minimum value, I can just ensure w will be greater than that minimum, okay? Greater than that minimum. Alternatively, you could also have the graph as this, where the maximum, you don't want it to be any more than this maximum, okay? So you could potentially have a graph where it looks like this. You see, that makes one x-intercept, two x-intercept. What you don't want is this second one to exist. So it can be anywhere but below a certain point. So w needs to be less than some sort of point, the maximum height that it could be. So the first question really is well, what does a graph look like? Okay, and you can do all this on your calculator, or you can just find out the turning points. Now, how do you find the turning points? You can do the derivatives. I can say, and you would probably do this on a calculator. So you do dy dx. You want to find your stationary points. Okay, now I'm going to quickly pop up my CAS calculator on the computer. Come on, load. While this is loading, how are you? I think I'm going to upload this on YouTube so everyone in the world can see how noob you are. Okay? Because I don't think this file is going to fit in your email anyway. And I don't have you on Edmodo anymore, so too bad. It's gonna be viral. All right, oops, I added a graph. I'm gonna go add calculator. Okay, I'm gonna make this larger so you could see. So what was my graph again? I had y equals to, so I'm gonna do define f of x equals to x cubed minus 9 times x squared, and what is that, plus 15 times x. Okay, I'm not going to put the plus w because this is your f of x, and what you can think of as whatever the graph is plus w only shifts the graph up or down. So what you want to know is, what is the graph? What does that graph look like? What does f of x look like? Which is that. What does that graph look like? And you can graph it. You can go over here and graph it. And there you go, that's my graph. Now, obviously, if I wanted to shift that graph up, I'd say f of x plus 5. And you see, it's shifted up. It's the same graph, it's just shifted up. Okay? Maybe I can zoom out menu 4A just so you can, oh, it's terrible. How do I go back? Okay, menu 4.1, let's make it -20 to 20. You see, like, it's just a shift. See, all I'm doing is the plus W has only shifted it up. Now, if I change the graph, let's do this. If I change the graph, instead of plus 5, watch, if I do minus 10. You see how it shifts the graph down? It's just taking the same graph and I'm just shifting it up or down. That's what W is. So, what you want is you want to make sure that the maximum, when I add, it doesn't pass the x-axis, because right now I've got 3 x-intercepts. Now I can trial and error all I want. I can do plus 1, and it's still not good enough. Maybe if I did minus 3. You see, it's going down. I still got 1, 2, 3 x-intercepts. Maybe if I now do, you know, like minus 5. Oh, it's getting there, and then maybe, you know, minus 15. There you go. Now I've got one solution. But the question is, how high can it be? So it's obviously negative something. And that's what I want to know. I want to know this maximum value. What's my maximum y value? So that when I minus it, it's just below. So that's what I'm looking for. I'm looking for that maximum here. Now, because I'm at the calculator section, I might as well just show you how to do it through the calculator. So, you know, I can just go this graph. Now, you see it's a maximum of 7. So if I then said, okay, let's take the red graph and I just minus 7, you see it just sits. See that maximum? It just sits on the x-axis. I've got 2 x-intercepts for the red graph. That's what I don't want. So as long as W is less than -7, I'm good. So for example, -7.1. It should be slightly off the x-axis. And I can prove that to you by doing this. Menu 6.1. If I asked you to find from here to here, you see there's no x-intercept. And all I did was just 7.1. There's no 0 found within the specified bounds. You see what I'm doing? So I already know the answer is W has to be less than 7. Minus 7, of course. Less than -7 by whatever. Why -7? Because I'm subtracting it. I'm translating it down. That's what I'm doing there. Okay? And so I just found the maximum. That's all I did there. And then I know my W value for this. But at the same time, I've also got the minimum for this point. I can add. Now, I need it to be greater than a certain amount. Now, you can find that out just by going menu, 6, minimum. And again, I'm choosing this. So minimum's -25. So if I now took the red graph, well, let's have a look. If I now took the red graph and I said add more, or just 25, just add 25. You see, it'll just, whoops, did I do add? No, I didn't. Plus 25. You see, it just sits. I've just translated -25, add 25. It just sits on the axes. Now I've got 2 x-intercepts, 1, 2. So what I want is it not to be 25, but it has to be greater than 25. And I can prove that again just by saying 25.1. And you'll see now there is no x-intercept here. See? No x-intercepts. Whereas there's only 1 x-intercept here. So that's ensuring that I only get one solution. I can't believe this is taking me 10 minutes to explain. But there you go. It shouldn't take you 10 minutes to do this question. As you can see, all I did was just found the maximum, minimum. Now you could have done it through the calculator section here. You could have done, well, what is that again? Shift minus x, f of x equals to 0. You can say solve for this, so solve for the derivative where x equals 0. Okay, and so you got x equals 1 and 5, and then to find out your y values, you can sub f of 1, f of 5. Okay, and then you could have done the same thing. But hopefully this graphically would have made more sense to you as to what we're really doing. And that's a typical question, so keep that in mind. Okay, I'm gonna pause the video here and then make another chunk, otherwise it's gonna be a huge file. Okay, that's question 18. So answering my point again, I said W had to be less than -7, because that subtracts down, taking the maximum, you're bringing it down. It has to be less than -7 but not equal to that, and W needed to be greater than 25, which brings the minimum up. Okay, and that, which one would that be? That's D. Voila, done. Too easy.